This will be a lesson on fileIO. I have a program here that reads a set of numbers from the console and then computes its average. It's a very simple program in which we currently have console I/O where the user is prompted, and then repeatedly the program scans from the keyboard numbers to be read in. One aspect that I want to remind you about scanf is that it does return a value. If the scanf was successful, will be equal to the number of tags that have been read in. In this case, I'm asking for one number. If a number was successfully read in, the value returned will be equal to 1. We're going to use this to determine when the user has finished entering its list, because the user will enter a number with a space between each one and then enter Q to quit. Q is a character. Q does not fit the floating point tag here, and so scanf will return 0, and that is how we're going to exit the loop. To quickly run this to show you, we are prompted by the program to enter a list of numbers. I'm going to enter in 3 numbers, so 3, 4, 5, and then I'm satisfied, so I'm going to go quit. 3 numbers have been read in, and the average of 3, 4, and 5 is 4.0. I've run my program. We want to now instead read these numbers in from the file, because sometimes I may not want to enter 3 numbers, but I may want to enter 1,000 numbers, and it's just too tedious. The goal here is to say, I want to have an existing file, okay, for instance in Notepad, and instead of typing them in, I want to go 3, 4, and 5. I want to be able to save this file permanently and then have my program read in the numbers. A beginner's tip for when doing fileIO is to save this data file in the same place where your program is. If I go over here and I open up my properties, I find out that my program is currently stored at this location. So if I open up my browser, I want to store this data file inside this location. So I'm going to do that. I'm going to save, and I'm going to go into Pellis projects. I'm going to go into my fileIO project, and it's here where I'm going to go. This is my data, and I'm going to call it data.txt. So you see now, we should see, we now have data.txt, and it's this file over here. This is where I want my program now to read in my data. So we're going to take the original console I/O and we're going to change it. Instead of prompting, what do I want to do is I want to open up the file. That's the first thing that we need to do, is instead of prompting, we go fopen and we give the name of the file data.dat, and this assumes it's in the same directory. It will change. You can put it in any directory, but for starting, we're going to leave it in this directory, and we're going to say we're going to open it for reading. Full details of this function is available on the C reference libraries. So the first step is to open the file. Now, instead of reading from the console, I'm simply going to go fscan. I'm going to scan from the file, but I have to tell it which file to open. The key to fopen is it returns a file handle. We've given it a name, we've said we want to read, but it returns a file open. So we're going to put equals, and on the other side of there, we're going to say it returns a file handle. Okay? And the file handle is of type pointer to file. You call fopen, you supply the name of the file, you say that you want to read, later on we will write, and then you take what's returned by this function and you put it into a variable that is declared of file type. Now, to use this file, we want to read from it, so that we now replace any scans Fs with fscanf. Okay, so fscanf. And as well, fscanf requires the same information as before, the same variables, the tags and the variables, but now it needs to know what file to read from, because potentially we could be reading from different files. So this is where we insert the file handle that we have received from our previous fopen. So we open the file, it returns a handle, and now we use that handle whenever we read from that file. We go through here, we run our program, and the key now is the final step is that we want to close this. So we use fclose and we say we want to close this file. Closing the file returns the file resources to the operating system, and it cleans up before we leave our program. So in summary, to do this, whenever you do fileIO, you have to open the file. You can repeatedly read from the file, and then you have to close from the file. The final aspect of converting our console IO program into our fileIO program is to handle termination, is to handle the case where we reach the end of file. fscanf will still return whether or not we've correctly received it. But in this case, we don't have a user that's going to be entering a number, and then queue to quit. Instead, what we're going to do is we're going to use one more function, and we're going to say while we have not reached the end of the file, because at the end of the file there's this special hidden character called EOF, end of file. And so we're going to call another function here, and this says while we have not reached the end of file in this particular file handle, we're going to keep on trying. So we could also be safe, and we could say while n items is equal to 1. So while we have not reached it and while we have valid data, we're going to keep on going like that. Now when we run it, you see that the program has run automatically without user input, reading the file, reading in the 3 numbers, and just to prove it, reading in the 3 numbers that we have put, and computing its average. Okay, so let's say we want to try and run it again, and I want to now put in more numbers. If I save that, I now run it again, and you see that 1, 2, 3, 4, 5, 6 numbers have been read. Their average is 10.3. So that's the benefit of fileIO, is that you don't have to have all this console IO where you're typing in and you may have errors in that. Now before I finish, I want to point out a common programming idiom that you should practice, is that it's related with file open. Whenever you call file open, it is recommended that you error check the file handle that has been returned to you. For instance, if I come up here and let's say for now I'm going to rename it and say it's hidden. What I've done is that when this program runs, it's going to try and look for this file, but this file won't exist. If I run my program right now, oh, I get a major error. My program crashes. We don't want to have that kind of behavior. We want our program to terminate gracefully upon having an error. It's incumbent upon you as a programmer to look for these kind of errors. So after opening a file, it is typical to test whether that file handle is valid. The file handle is valid as long as it's not equal to the special value known as null. So I'm going to go, if the file handle is equal to null, what I'm going to do is I'm going to print out a nice helpful message, no such file. Is that correct? And then I'm going to return with poor error code. Okay, and so now when I run this program, you're going to see, oh, no such file, and the process is returned. My program did not crash. Okay, and the user's informed and they can go and fix the error. So that's our little introduction to fileIO. There are more things to learn. For instance, you'll notice that what we haven't done is we have opened a file for reading. What if we want to open a file for writing? What if we, instead of printing out to the screen, what if we wanted to print the results to a file? What would you have to do? I'm going to leave you with that thought. And remember, file operations consist of opening a file, doing the file operations, scanning or printing, and then closing the file. Thank you very much.